All right, let's take a look at a graph that will have a different type of symmetry here. Let's sketch a graph of x minus 2 squared plus y squared equals 9. Now we know that this is going to be a circle, and so what we need to do is we need to find the center and the radius. So the center, the x-coordinate of the center is the number that's being subtracted from x in the parentheses. That's going to be 2. The y-coordinate of the center is the number that's being subtracted from y. And in this case, there is no number there, so that ends up being 0, because y is the same as y minus 0. Then the radius, we know the constant term is the radius squared. So if r squared is 9, that means the radius r has to be 3. So we've got a circle with center 2, 0 and radius 3. Let's sketch that. The center 2, 0 is right there. If the radius is 3, then we're going to draw in our guide points, 3 units in each direction from there. And let me try to draw an okay circle. All right, we have this one. And so this has a special type of symmetry as well. Instead of being symmetric about the y-axis, this is symmetric about the x-axis. Now, I will be honest with you, there are other types of symmetries that a circle has. If you draw any diameter of the circle, it's going to be symmetric about that diameter. But we're specifically focused on symmetry about the axes at this point. So this one is symmetric about the x-axis, because if we have a point anywhere on the circle, if we have a point anywhere on the circle, let's say x comma y, then the point that's reflected across the x-axis, x comma negative y, is also on the circle. So we say this is symmetric about the x-axis, and the graph is unchanged. Let's see, graph unchanged when reflected about the x-axis. And so if the point x comma y is included, so is the point x comma negative y. We can see a lot of similarities between these rules for symmetry about the x-axis and the rules for symmetry about the y-axis. All right, and then we're also going to have a similarity when we're dealing with the tests. If we want to test whether an equation gives us a graph that is symmetric about the x-axis, what we can do is replace y with negative y and see whether or not we end up with a new equation that's equivalent to the old original equation. We can do that here. If we take the original equation and we replace y with negative y, then that's going to give us a negative y squared, because we've taken the y squared and we've replaced y with negative y. But again, a negative times a negative is a positive, so negative y times negative y is going to give us a positive y squared. And that is going to give us back the original equation that we started with, so we know that this has the correct symmetry. We're going to look at another example that has the same symmetry. This is going to be a little bit different from graphs we've seen before, but I think it'll be good for us to take a look at it. let's sketch a graph of x equals y squared minus 4. Now usually we have y equals something with x. Now we have x equals something with y. And what we're going to do is we're going to make a table of values with x's and y's to try and figure out what this is going to look like. You might actually have an idea of what this might look like. Maybe you can take a guess, and we'll see if that guess is right. But instead of picking values for x and then solving for y, I'm going to pick values for y and then solve for x, because it's going to be a little bit easier here. So for y, I'm going to pick -2, -1, 0, 1, and 2, and we're going to plug those in and figure out what x is. So let's see, I'm going to make another row for the work. So when y is -2, we've got -2 squared minus 4. -2 times -2 is +4, so we get 4 minus 4, which is 0. Now we can plug in -1. -1 times -1 is +1, so we end up with 1 minus 4, which is -3. If we plug in 0, 0 squared is just 0, and 0 minus 4 is -4. Let's try the positives now. 1 squared is 1, 1 minus 4 is -3. 2 squared is 4, 4 minus 4 is 0. So we've got our points. Let's sketch this graph. All right, we've got the point 0, -2. We've got -3, -1, -4, 0, -3, 1, 0, 2. Can you tell what this is starting to look like? And was it the same thing that you were guessing earlier? We have a parabola now, but the parabola isn't opening upwards or downwards. It's opening to the right, and that's because instead of y equals x squared plus something, we've got x equals y squared. And that changes the orientation of the parabola. Now, we can see just by looking at this graph, it looks like we have symmetry about the x-axis, because every point up here has a corresponding point down there, and they are equidistant from the x-axis. But if we want to test this, the test says that we replace y with -y. And if we do that, if we test this, we've got y equals -y, quantity squared minus 4. And a negative times a negative gives us a positive, so that's going to be +y squared minus 4. And we can see that this new equation is equivalent to the original one, so we know that this will have symmetry with respect to the x-axis. We're going to be seeing more graphs like this in calculus. We might see some more this semester. I'm trying to remember off the top of my head. I can't think of any great examples, but sometimes we will see graphs where instead of y equals something with x, we have x equals something with y. And there's actually a word that we can use kind of to describe these sorts of things. It's called a function. It's actually something we're going to be seeing very, very soon, but I'm not going to talk about that anymore now. What I want to do is I want to move on and look at the third type of symmetry.